Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at translations of log graphs. So remember, translations is when we shift the graph left or right or up or down. In a previous video, we looked at graphs like this. For example, the graph of y equals natural log of x. They all have this same shape where they get bigger quickly and then they slow down. They increase at a decreasing rate. So now we're going to look at graphs of this form. We still have log base A, but we've added something in the brackets and outside the brackets. So we learned about this last year. I'll just quickly refresh your memory. So the number that goes in this bracket shifts the graph left or right. Unfortunately, it's a bit annoying. The number that goes here shifts it the opposite way than you would expect. So the graph goes left if this number in the brackets is positive, and right if the number in the brackets is negative. So that's kind of the opposite way that you'd expect. This constant here outside the brackets shifts up or down, and this one does work the way you'd expect. It shifts it up if this number is positive and down if this number is negative. So other than these two shifts, left and right or up or down, these two graphs are exactly the same. They have the same shape and everything. So let's say I want to graph this function here. So what I'm going to do is I'm going to use this graph, y equals ln x, and I'm just going to translate it. So how much do I translate it? Well, this number in here, -2, means I translate it 2 units to the right. Remember, the number inside the bracket goes the opposite way that you'd expect. Because it's negative, we go to the right. So this number here, outside the brackets, that translates up or down, and it goes the way that you'd expect. So -1 means it's going to be translated 1 unit down. So other than that, this graph will be the same as this graph. This graph I'm going to draw in red is going to be the same as green, except shifted 2 units to the right and 1 unit down. So normally for y equals log a of x, the x-intercept is 1, because e to the power of 0 is 1. So this point will be shifted 2 units to the right and 1 unit down. It will go through this point here. So remember that y equals log a of x has an asymptote at x equals 0. The y-axis is an asymptote. Y equals natural log of x never hits the y-axis. But because we're shifting this 2 units to the right, so too the asymptote will shift. This will be the new asymptote of this graph here. So when you have a function of this form, its asymptote is the vertical line x equals minus h, the negative of what's in the brackets. So here, what's in the brackets? -2, negative of that is +2. The asymptote is this line x equals 2. Remember, the asymptote occurs in logs because we can't take the log of 0. I can't substitute x equals +2 into this because then I'd be taking natural log of 0, and you know that that doesn't exist. So one more thing we might look for is the x-intercept. Of course, this graph here is not going to have any y-intercepts because the graph can't go to the left of this asymptote. Sometimes these equations do have a y-intercept if you move the asymptote to the left of the y-axis, but this one doesn't have a y-intercept. So let's find its x-intercept. So to find the x-intercept, I'm going to let y equal 0. So all I'm going to do is take this equation and change y to 0. So then what I do is I add 1 to each side, and I've got 1 equals log base e of x minus 2. So the way I undo log base e is raise each side to the power of e. So I get e to the 1 equals x minus 2. So that means if I add 2 to both sides, x is equal to e plus 2. And if you put that on your calculator, you get about 4.71. So the x-intercept is about here at 4.71. So otherwise, it's going to look exactly the same as this graph here. So it's going to go like this. It's going to come through its x-intercept, and then its growth is going to slow. So you can see the red graph is the same as the green, except it's been shifted. To go from green to red, you shift 2 units to the right and 1 unit down. Otherwise, these graphs are identical. So make sure you make use of your graphics calculator when graphing these. You can also use a table of values if you need more points along this curve to see what it will look like. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.